Hey everyone, in this video we are going to discuss the concept of an ordered pair. Don't worry, an ordered pair is actually a mathematical object and there is no need to worry about it. Well, there are several approaches to introduce the concept of an ordered pair, and one of them, if you like, is known as axiomatic approach. Whatever the name may be, it does not matter. Now, let's see what we do in this approach in order to introduce the concept of an ordered pair. In this approach, we assume the existence of a certain type of object with the desired property. In this approach, we don't define the concept of ordered pair and just state explicitly the fundamental or defining or the characteristic property. These fundamental, defining, and characteristic are all the different names of the same property of ordered pairs as an axiom. Actually, what we do, just like we do in the theory of sets, we axiomatically we don't define the term set. Instead, we assume there exists an object called set which satisfies all the Z(10) axioms. This is one of the approaches to construct some theory and is known as axiomatic approach or axiomatic method. Now, in axiomatically speaking, an ordered pair has no definition. We don't define it, but what we do, we state explicitly that property in which we are interested most. And an ordered pair is just like a primitive or undefined term. If we treat it axiomatically, then what we are interested in is its fundamental property, not the concept of ordered pair itself. We are interested in its fundamental property more than the ordered pair itself. That is what axiomatic approach is based on. If you are interested in the properties of some object but not the definition of the object itself, you have to take the path of axiomatization. That is what this approach is based on. So in this approach, we don't define actually an ordered pair. Rather, we assume there exists an object that we call an ordered pair and denote that ordered pair by this symbol, okay? And assume that this object satisfies this fundamental property. So actually in axiomatic approach, we don't define an ordered pair. Rather, we just state its fundamental property in which we are interested most. And here we go. In this approach, let us suppose that I have two objects A and B. Then an ordered pair of objects A and B is an object which we denote by this symbol or this symbol and satisfying this fundamental property. That this is the property that we want an ordered pair to have. If somebody says me that I have an ordered pair and I define it this way, I have no objection to accept his definition if that definition implies its fundamental property. So, if I have two objects A and B, then an ordered pair of these objects A and B is a new kind of object, and that object we denote by this symbol or this symbol and satisfies this fundamental property. This fundamental property says that an ordered pair A and B is equal to the ordered pair C and D if and only if this symbol is read as if and only if this thing happens. What? A is equal to C and B is equal to D. I mean, this statement tells me that if I have two ordered pairs which are equal, if it is given that those two ordered pairs are equal, then what should I imply? I should immediately imply that A is equal to C and B is equal to D. On the other hand, if I am given that I have two ordered pairs such that A is equal to C and B is equal to D, then you should immediately imply that those two ordered pairs are equal. That is what by implication means. This thing implies this thing, and this thing back implies this thing. So this is what an axiomatic approach to an ordered pair is. Let us name this fundamental property by this P. Let us wrap up what we have discussed in this approach. In this approach, in axiomatic approach, we don't define an ordered pair. Rather, we assume its existence and state its fundamental property as an axiom. Now, you should note one warning to this very approach, and here it is. Since this approach does not define the concept of an ordered pair, and the property P, that is this property, talks about two ordered pairs. Obviously, this property is a statement actually, which talks about two ordered pairs. So that is what I have wrote down here. In this approach, actually, we don't have definition of an ordered pair. So this note tells me that since this approach does not define the concept of an ordered pair and the property P talks about two ordered pairs, so logically we cannot prove it. I mean, because this property talks about two ordered pairs, if someone asks us, prove this statement, prove this fundamental property, in this approach, we will not be able to prove this property, because to prove this property, I would definitely need the definition of an ordered pair, because this approach lacks, or it does not give us the definition of an ordered pair. That is why we state this fundamental property as it is axiom. And this defect, or to prove the aspect of proving this fundamental property, needs a different approach. That is what we are going to discuss in the constructive approach. Bear with me. Here is second property. You should note one more thing here. In this approach, property P is actually axiom of equality of ordered pairs, two ordered pairs. Obviously it is. In the note second, I am saying that this property is actually an axiom of equality. Why axiom? Because I have no proof to this very thing, to this very statement. I cannot prove it. That is why we have taken it as an axiom. So actually this property is actually the statement of axiom of equality of two ordered pairs. That is what is written here. One more thing you should note in this approach is that these A, B, C, D are arbitrary objects. It could be anything. It could be an aeroplane. It could be a house, a car, pen, book, mobile phone, anything. So the nature of these A, B, C, D is arbitrary. They could be of any type. So this was one more thing that you should note in this approach. Now we are going to discuss the constructive approach to an ordered pair, to the concept of ordered pair. So here it is. In this approach, we formally define the concept of an ordered pair in terms of the concept of set itself. What I am saying here is that actually this approach distinguishes from this approach fundamentally in this respect that in axiomatic approach, we don't define an ordered pair. In the constructive approach, as the name suggests, we actually try to formalize the concept of ordered pair. We try to give the precise definition what an ordered pair is. But we know until now we have just encountered or to some detail understood the concept of set. So is it possible to define the concept of an ordered pair in terms of set? Is it possible to boil down the concept of an ordered pair in terms of more basic object, which we call set? Yes, it is possible. That is what constructive approach to an ordered pair talks about. So what we do in this approach, we formally define the concept of an ordered pair in terms of the concept of set itself. So as we know, this approach actually defines the concept of an ordered pair in terms of set. So we must be able to prove the fundamental property from that definition. If I choose a definition which does not imply the fundamental property of an ordered pair, then that definition would be useless. So once we have the definition of an ordered pair, we will be definitely able to prove logically the characteristic or fundamental property of ordered pairs. You should note one more thing. If you have objection with this definition, give me some other definition which will be more simple, I mean elegant, and must imply the defining property or the characteristic property of an ordered pair. I would have no objection to accept that over this definition. Come with at least one definition. I'll be waiting. Comment in the section on the video. So no matter how we define an ordered pair, the definition must imply logically its defining property. Otherwise, that definition would be useless completely. So here we go. This definition that we are about to discuss or about to state is the formal version of definition of an ordered pair. Remember that in this definition, we are going to define the concept of an ordered pair in terms of sets. Remember this note. Now, if I have two sets, arbitrary sets, A and B, such that A is an object of A, I mean A belongs to A and B belongs to B, then this expression defines an ordered pair. Then what this definition says me, an ordered pair which we denote by this symbol is defined as this symbol is read as defined as the set which consists of the elements this one and this one. And if you note, this element and this element are themselves sets. Actually, it means that A and B, this object is the symbol to denote a set whose elements are themselves sets. Okay, so an ordered pair is nothing but a set. Now you should note one more thing here, that in mathematics, if you have a set whose elements themselves are sets, mathematicians prefer to call those sets as collections or classes. So I can say, or I can rephrase my definition of an ordered pair as an ordered pair A and B is the collection of the sets this set and this set. So the formal version of the definition of an ordered pair says me that an ordered pair is nothing but a collection of two sets. Now you should note one important thing here, that if using this definition and the definition of equality of two sets, I mean the axiom of additionality of sets, which I have already discussed in the last videos, using this formal definition of an ordered pair, you would be able, and using the axiom of extensionality, in other words, the definition of equality of two sets, you will be able to prove the defining property of an ordered pair. That is, an ordered pair AB is equal to ordered pair CD if and only if this thing happens. Using this formal definition and the axiom of extensionality of two sets, you will be able to prove this fundamental property of ordered pairs. And in it, hopefully, we will prove the defining property. I mean, using this formal definition and the axiom of extensionality, I will prove that this statement or this property of the ordered pairs actually holds. Thanks a lot.